What's up, everyone? So today we are going to know about how to write a self-driving code, self-driving car code in Python. So it is basically a self-driving car simulation code on which we are going to write or create a. We will use it as a mini project or like for a minor project in our colleges, like for BTech or for MCA students. So for that it will work. You can take it as a midterm project or for like minor project or for presentation. You can also use your self-driving car simulation tool. So the this is how you are going to like create one minor project for your college. Okay. Second thing is like this will be the code for which in which we are going to know how our self-driving cars will work, and for that we need some prerequisites like to know how to show how our self-driving car code will work. So first of all, we need some images, like these images are here. First image is like, first of all, since we are writing the code of self-driving car, so we have to we need an image of a car which will be like Tesla. Since I have used this Tesla model car, and it is like animation. You can find these all animations of Google as well. And if you want, I can add these cars images with the help of Google Drive link in the description of the video, and you can add these images in your practice command or your folder as well. Second image is your track. So this is the track one. It is the initial position, it is the final position, and we need to make sure that the place where the position where the white strip ends, the car should stop right here and should not go beyond this position, because maybe here it is a ditch or some kind of like river or something, so it will cause an accident. So we need to make sure that our car simulation model or our sensors of the car works properly, and it should make the car stop right here. Similarly, we have other tracks as well. Like here you can see there is a red strip, and car should have to stop before this red strip ends. And here we can see that Donald Trump is standing. In the third image, in the third track, you can see Kim Kardashian is waiting for you here, and we have added some other buildings and poles and stop sign as well. In the fourth image, if you take a look, Nicki Minaj is standing for you, waiting for you here at the stop sign. And in the fifth image, we can see that there are restaurants and school as well, and there is a stop sign as well. And the sixth image, we are going to meet Elon Musk in our last track, which is the most difficult track. So what we are doing here, if we take a holistic scenario, we are making it more and more difficult for this Tesla car. So we have this Tesla car, and these are the few tracks. First track is the easiest one. Okay. Second track is like somewhat difficult than first track. We have made Donald Trump wait for you. Then in the third track, we have added Kim Kardashian. Kim Kardashian is waiting for you, and we have added some red strip, and car has to stop right here. Your self-driving car has to stop right here. In the fourth image, we have added Nicki Minaj, and Nicki Minaj is waiting for you here, and we have added some buildings and some other stop signs and some other things we have also added here. So we are making it more and more difficult to see how our self-driving car code will work in real life on the basis of this simulation. So let's start. So before starting, let's open your pygame or Visual Studio, whatever the IDE you have. Just open that IDE, and after that you have to install this library called pygame. So we need to install this pygame library with the help of pip install pygame. So since I have already installed this library, it is saying that requirement is already specified. But if you don't have installed it, please install it right now. And after installing it, it will show you like this, downloading pygame, and it will download the pygame system. And once the pygame is installed, we have to start coding. So to start the coding, we need to create a file for self-driving car, and we have to add all the images in that particular self-driving car simulation code. And for that, and after that, we have to start the Python code. So let's start. First of all, we will import pygame library, and then we will initialize pygame.print. Then we will initialize the window size for our pygame simulation libraries, like for pygame simulation UI, pygame.display.setFont, and we have used that we have added 400 ratio of window, and then we have track. Here we have added the track image, pygame image role. Here, suppose that we have added track first, track one, png, and then we have added the car image here. For the car image, we have pygame transform pygame image.root. We have added Tesla. You can add other car as well if you want. Like I have shown you earlier, it's just a simple car. You can add another car like this one, or we have some other cars like this and this. We don't need to particularly work on add that particular car as well. You can take this one or like any car for this project also tools. Let's take this one, let's download it. These images have white background, that's why make sure that there's copy. Background, we have this Tesla cars which have background, so like that we need one image. Download it. So let's test all these cars once the code is completed. So let's further and then we add the pixels of our car and pygame transform or scale, and we have added car. Pixels of car will be like 30,60. After that, we have added x and y axis for the cars. We have car x will be 155, car y will be 300, and we have taken focal distance. So why focal distance is taken? Let me tell you first. Focal distance is like on the distance from which distance our camera will record the pedestrian or like a road or some obstacle, and we have to stop the car. So for that we need to set a focal distance for our camera which is added in the car. So for a self-driving car, there are some few prerequisites. First of all is camera, then there are sensors, then sonar, facial recognition, voice recognition. So these are like some basic prerequisites on which we are going to work. So let's move further and let's add offset as well, like camera x offset. Initially both offsets are 0 and the y offset will be as well 0 as well. Offset. Then we have direction. Direction will be up. We go upward direction. If we take a look here at the edge, you can see that our car will be going upward direction. Then after that, we move right and down. Again, up, right, down, up, right, down. In these directions will be on. Okay. So then initially the drive will be true because we will drive, of course. After that we have to set the clock timer, which will be like pygame dot time dot clock. After that we will add the drive while drive from document pygame document get if driver do not want to drive, the car should not drive by itself. So that we have first of all initialize the pygame output, which means the game should not initialize by itself, or the car situation should not initialize by itself. Like if driver does not want the car to drive, the car should not drive by itself. For that we need to first initialize the put function. Since if the driver does not want to drive the car, or if the user does not want the car to move by itself, it should not move. Okay. Let's move further, and we need to set the clock timer. Clock 60 seconds. And then we have to add the cameras. Like X-axis camera, which will be like car express. Cameras 15. Similarly, cam Y, plus cam Y offset plus 15. And then we have to add some up pixel and down pixel as well. So for the up pixel, it will be like pixels will go up, window dot get window dot get it. Yes. Instance. Initialize for instance, that means select position, and then we have right pixel, and then so like these will be like some basic pixel positions. So initially our all the pixels will be initialized from the 0th position, and for moving upward we have cam Y, which is the y-axis, and y-axis will like the focal distance will be like differentiated from y-axis, so it will be like go lesser and till the white step will end, till the pixels of white till the end of the white strip, and once the white strip pixels are finished, the car will stop here. So like that our up pixel will work. Similarly our down pixel and right pixel will work. And let's read it. print up EX, right, and down itself. Send pygame to display as attributes. Set marks. These are some silly mistakes that I have done. So this is like our initial window of pygame. So we can see that 0, 0, 0, 0, 0 pixels are moving out further because we haven't added any pixels or any other images here. So that's why it is showing like this. Just move further and let's add some changing directions. Let's change directions. So I will like this direction up. Right, just 5. Then the direction will be right. And the x offset will be initially 30 pixels. And can't proceed. Pygame dot transform. Rotate, then rotate it minus 90 degree. Further. So once our direction is finished, so now we will move further to our right direction. So for the right direction, we will like Alice, Alice here, Alice. Right. Right, this is good. Down pixel plus 2. Let's take the hand offsets. So let's see and hand offset 0. F of x offset. 0, and gamma y of 0 will be pixels. Now let's move forward to the next direction, which is direction down. And now the cell is equals to, and then we can assign that is direction related. We will add the pixels to this direction. This direction of star y is 30. And again we will set the camera of 60 degrees. On the y of 0 and again star the transformation of direction will be like pygame will transform, and the rotation of star will rotate, and is minus 90 degree. The opposites go like going upwards and downwards, like plus 90 degree will go upwards and minus 90 degree will go downwards. So that's how it works. So upward and downward will be like minus 90 degrees, and again so here we have another if we will follow the expression LF direction goes to right and x equals to is not equals to 5 and pixel equals to 50 points. In that case we will say that coming in the up direction. So let's say if we take a holistic view, we will see that the down direction and right direction will be the minus 90 degree, and up direction and right direction will be in the plus 90 degree. Like we have added the plus 90 and minus 90 degree as per the rotations in our like curves and images. So as the curves will if we take the curves, if we have the more smooth curves, in that case, like we have to add some other angles. So like we have initially added as 90 degree because in the image we have all the rotations in 90 degrees only. So that's how it works. Okay. So let's move further and let's add the pixels here like car equals to car x 3. And camera x offset will be equal to 0. After that, we will transform the rotation. So, by transform row rotate, car to 90. So that's how our rotation will work. Now let's add the driver to the which direction it is to come. Direction equals to up, and pixel equals to 255. In that case, our car will move upwards, which means car y times 2. Car y minus times 2. Similarly, if direction equals to right and right pixel equals to 255. Rendition will create some errors and show that there is error in syntax. So again, we will call the car y. Direction equals to right and right is equals to car x equals to car x plus 2. If direction equals to down and down is equals to 255. We will call the car y equals to car y equals to we will move downwards again. Once it's completed, we will just add the return dot so for we will add the tracks track 0, 0. Share the track is 0. We will add some car. X and y pygame circle. This command we will list. We will make the car to rotate in some certain directions because of our increasing and decreasing of values like 0 to 255, 0 to 255 to 255 to 0, and 255 to 55 to 55. So like these will be the pixel values using which our self-driving car or like our image will move in further directions. Okay, so let's add the pixels here. So 0, 255, 0. Again, we will add some camera locations like camera X, camera Y, 5, and then we will just display the updated location. So like whatever the updated locations or position update will be here, so we can display all these. That's this code. Some source. And it's not solution the car again. So you need to show the car at least. So it was a typographic error, I should say it's syntax error. If you can take a look here. I haven't added the car. I have used the car. I forgot to add the car by and I have used this car. That's why it was showing this. So now let's test our self-driving car code. If you can take a look here, it is working properly and our car is standing in front of Pro Ultra. Now let's do for a car version. But that is car equals to 950. Here it is. Again, I have I forgot to. And let's now it is doing some other stuff. Zero. It's perfect. It's correct. Now let's further the right direction. So fine. Yeah, it is working fine. And the last track, which will meet where we will meet Elon Musk. So we Elon भैया से मिला दो and let's meet Elon Musk. Elon भैया Elon Musk. Yes, so here you can see that our code is working perfectly fine now, and as you can see here we met Elon Musk finally. That's how our self-driving car code works, and I hope you understand how the code works and how we have added the pixels and whatever images which we have added, and what are the directions, how we have added the directions of pixels, and with the help of like differentiating and integrating the pixels. So like these are like some basic tracks that we have added. If you want, you can add some other directions and you can add some other pixels as well. And after that, you can just run the code to check whether our model will work in some other tracks or not, or whether our self-driving cars works fine in some other directions or not. So for that, you can add some other tracks. So that's how our self-driving car works. And I hope you understand this code. And if you want the images, I will add the links to all the images of my Google Drive in the description. And apart from that, thank you for watching, and make sure to subscribe my channel. And happy learning. Bye. Thank you so much.